Thank you for coming. This is Psych 18 research methods, and today I'm going to talk about experiments. So just to recap some important concepts, remember that a variable is any kind of event, situation, or behavior, or even individual characteristics that can vary or change. That's why it's called a variable. So we count on the fact that this particular item is not going to be consistent. That's why it's interesting to us. We want to know what causes changes. That's why we're looking at the variable. An operational definition is a set of procedures used to measure a variable. So although a variable can have what we call a conceptual definition, where theoretically we know what is involved with the variable, we have to have an operational definition of that variable. And the operational definition has to be something specific, observable, and measurable. When we talk about relationships between variables, what we're looking for is systematic variation between the independent variable and the dependent variable. And there are different types of relationships we're looking for. So graph A shows you a positive linear relationship. That means as the value of one variable increases, the value of the second variable increases as well. Or when the variable value decreases, the second variable value decreases as well. So in other words, they move in the same direction together. When that happens, we call that a positive linear relationship. Graph B, on the other hand, is the opposite. It shows a negative linear relationship. So that means when one value goes up, the second one goes down, and vice versa. When one goes down, the other one goes up. So let's take a look. In graph A, we're looking at the relationship between self-esteem and self-efficacy. So always when you're looking at graphs, the line on the bottom where it says self-esteem, that's known as the independent variable. That's the one that we believe will cause change or influence the second variable. The variable that is vertical, self-efficacy, we call that the dependent variable. We measure the dependent variable because we believe that a change in the independent variable will cause a change in the dependent variable. So as we can see, as somebody's self-esteem increases, you go from low to high, their self-efficacy increases as well. So self-efficacy and self-esteem, the values move together, and so we say it has a positive linear relationship. On the other hand, let's take a look at graph B. Now the independent variable is anxiety, and our dependent variable is school performance. And what this graph is showing is that as anxiety increases, school performance decreases. And that's why we call that a negative linear relationship. Some other relationships we're looking at. Graph C shows what we call a curvilinear relationship. So in this graph, it's number of activities and GPA. What we see is that as the number of activities increases to a certain point, GPA increases as well. And then there is a high point, and suddenly it turns. And instead of a positive relationship, it becomes a negative relationship. So there are certainly certain constructs where that happens, where you almost have like a sweet spot where it peaks and then suddenly it goes down. So in other words, here, number of activities, there's a certain ideal amount of activities that's associated with increasing GPA. But if you have too many activities, it's going to negatively impact GPA because you don't have time to study anymore. That's really what's happening here. And then graph D shows no relationship. So in this graph, we're looking at amount of crowding and performance level for maybe for a test. So how many people are in the room versus how well somebody performs. When it's a flat line like that, it means that there's no correlation between the two variables. Okay. Any questions? Okay, correlation coefficient. So the correlation coefficient tells us how strong the correlation is. So a correlation goes anywhere from -1 to +1 in value. 0 means there's no correlation. So when we're talking about the strength of the relationship, what we want to look at is how far away is it from zero? The further away it is from zero, the stronger the correlation, right? So the negative and positive don't tell you the strength of the correlation. They just tell you the valence, whether they move together, which is positive, or they move opposite from each other, which is negative. But the strength is actually indicated by the value of the number. So the distance from zero indicates strength. So in other words, if you had a correlation with negative 0.25 and you have a correlation that's positive 0.25, they're actually the same strength. It's just that one is a positive relationship and the other one is a negative relationship, but the strength is the same. So what you're always looking for in terms of strength is how far away it is from zero. The negative and positive part do not make a difference. So remember, another recap is our goals of research. There are 4 goals of research: to describe, explain, predict, and control. Among these 4 variables, 4 goals, only experiments can establish explanation or causation. Experiments also focus on control, so it's something to keep in mind. When we talk about experiments, it's considered the gold standard of research. We should only be using experiments if we are trying to establish causality, right? So it's the only form of research to establish causality. We often use it for interventions and treatments. It's expensive to conduct experiments, so we want to make sure we use it in a way that's appropriate. As I mentioned before, we have 2 main variables that we're looking at in experiments. The IV is the independent variable, right? We consider that the cause. So remember, experiments are meant to establish causality. And so what we want to do is take a look at our independent variable, and we are going to manipulate it. We're going to change its value somehow. And what we're expecting to see is when we change the value of the IV or the independent variable, we're expecting to see a change in the dependent variable as well. So dependent variable is considered the effect, and that's what we measure. The independent variable is considered the cause, and that's what we are manipulating. So experiments among the different types of validities have the highest form of internal validity. Remember that internal validity is your ability to draw conclusions about the cause and effect of your independent variable. It talks about the strength or the integrity of the structure of your research design. In order to establish internal validity, you have to have certain characteristics met. So 1, you have to establish temporal precedence. In other words, you have to manipulate the independent variable before you see a change in value in the dependent variable. We want to see there's covariation of those variables, that when you manipulate the dependent variable, the value of the dependent variable changes as well. We also want to eliminate plausible alternative explanations. And we do this by either using random assignment, or we control extraneous variables. So as I mentioned, you get covariation, establish temporal precedence by manipulating the independent variable and looking for a change in the value of the dependent variable. And you rule out alternative explanations through random assignment and experimental control. So ideally, when you have an experiment, you have participants and you essentially have their names in a hat and you randomly assign them to either be in the experimental group or the control group. By doing this, what we're trying to do is avoid systematic variation between the characteristics of those who are in the experimental group and the control group. This is because we want only the manipulation of the independent variable to cause change in the dependent variable. So with non-experimental methods, right, we start off talking about experiments because there are very specific features that define an experiment. Essentially, everything else is a non-experiment. So in non-experimental methods, there could be covariation. Many non-experimental methods, we're looking for correlations. In a correlation, we're looking for systematic variation. What we normally don't have in non-experimental methods is we don't have the establishment of temporal precedence because we are not manipulating any variables, right? So because we're not manipulating variables, we are not establishing temporal precedence, and often we cannot eliminate alternative explanations as easily as we can with an experiment. So with correlations, you remember there's systematic variation between the independent variable and the dependent variable. But if there's no manipulation, we don't know which variable is causing which, right? We don't know if it's drinking coffee that makes you more alert, or maybe we are more alert after people are more alert like to drink coffee, right? We're not totally sure unless we manipulate it. Then there's something known as the third variable problem. It could be that in a correlation, we see this relationship, this predictable change in values between two variables, but maybe there's a third variable that's causing that relationship that we're not even thinking about. So an example of that would be watching violent television and levels of aggression in children. So we see that as a very, actually quite a consistent correlation between those two, between kind of exposure or watching these violence shows and also levels of aggression. What research has established, though, is that there's actually a third variable that mediates this relationship between watching violent TV and aggressive behavior, and that is the presence of a caregiver or parent. Because if a caregiver or parent is watching the show with them, they can actually explain what's going on. And so kids who watch shows that are violent, if they're watching it with people who, family members or caregivers who can explain why this violence is happening, that actually reduces that component of the aggressive behavior also being shown in the children. So that's an example of the third variable problem. If we know, good researchers will look at existing studies to really get an understanding of this variable they want to learn about. And so oftentimes, by looking at what's already been established, you can get a sense of which variables are related to each other. And there very well could be a known third variable, and we would call that a confounding variable. So a confounding variable is one that we're not directly studying in the experiment, but it exists, and moreover, it changes systematically along with the dependent variable. And so we're not sure what's causing that change in the dependent variable. Is it the manipulation of the independent variable, or is it the presence of this confounding variable? So a good researcher needs to know what possible confounding variables there are and control for it, either eliminate it environmentally or control for it statistically. So let's talk about extraneous variables and confounding variables. An extraneous variable is anything that changes and also exists in the environment. So an example of an extraneous variable, if we're talking about, drinking caffeine and cognitive performance, what can an extraneous variable be that exists? Well, it could be the time of day. So if the experiment is happening in the morning, that could very well have a different outcome than if the experiment happened late at night, right? So to control for that, we would make sure that all the experiments are happening at the same time of day. So that's an example of controlling an extraneous variable. A confounding variable is a type of extraneous variable that causes that, as I mentioned before, systematically varies along with the dependent variable. So we don't know what's causing that change in the dependent variable. Is it the independent variable that we're studying, or is it this extraneous variable that maybe we didn't control? So it's very important for researchers to look at previous studies and try to anticipate what could possibly be any confounding variables and then control for them. So when we evaluate research, I've kind of mentioned it already, we want to look at different types of validity. So we talked about internal validity, where you are looking at the structure, the integrity of the structure of your research design. We also want to make sure we establish construct validity. We do that by making sure that the operational definition of variables is consistent with what exists in the literature, right? Internal validity, because your research design structure is so strong, it gives the researcher the ability to draw conclusions about causal relationships. So the stronger your internal validity, the stronger your confidence that, yes, it is the independent variable that's causing change in the dependent variable. We also want to look at external validity. Remember, external validity has to do with our results. To what extent can the results be generalized to other populations or settings? If the results can only apply to your sample population, that's not going to be very helpful to other people. So we want to make sure that we have both internal validity and external validity. And remember that it's a negative relationship. The higher your internal validity, the more you have control over all these extraneous variables, the lower your external validity, because all that control doesn't exist in the real world, right? So external validity, usually the higher that one is, the more natural you're leaving the circumstances. But the weaker your design will be because you're not controlling for the extraneous variables as much. So as a researcher, you have to make that decision. My recommendation is that you would have strong internal validity. You want the design and structure of your research to be very strong, and then you can establish external validity by replicating it in other contexts and with other samples. Any questions about validity? Okay, conditions. When you talk about conditions in an experiment, what you're really looking at are levels of the independent variable. So we're looking at treatment conditions. If we're looking at a study on caffeine intake and cognitive performance, right, the most basic two levels you would have is no caffeine at all, and then caffeine, and maybe you would say 2 cups of coffee or something like that. A better way to establish that relationship would be to have several levels. So maybe no caffeine, 2 cups of coffee, 4 cups of coffee, 6 cups of coffee. So now we're having different levels of caffeine, and we can more accurately determine how much caffeine really is needed in order to see if there's a change in cognitive performance. So the amount of manipulation that you're exerting on your independent variable does make a difference in terms of the strength of your experiment. So the most basic conditions are just treatment and control. With a no treatment control condition, what we're talking about is that somebody just wouldn't have caffeine. The problem is that we actually don't want the participants to realize which control condition they're in. So oftentimes, instead of having it nothing at all, we'll have what we call a placebo control condition, where they think they're getting caffeine, but they really aren't. So that's because the psychological power of suggestion actually does impact how participants perform in studies. So the more we can have participants believe that they're in the experimental group, the stronger the structure of our study. So waitlist control, so no treatment control condition means they would have no coffee, for example. Placebo control condition would be that they have a drink, but they don't know whether it's coffee or not. And then you have a waitlist control condition where they get coffee, but it's staggered, it's later on. The reason that we do a waitlist control condition is because it is no longer considered ethical to keep somebody away from a treatment that will help them. So it's not so much about coffee, but maybe if it's an illness like cancer, for example, somebody who is randomly assigned into the control group, you don't want to deny them treatment that could possibly save their lives. So instead of doing no treatment or placebo, what you might do is start treatment maybe 2 or 3 weeks later than that in your experimental group. And so you can still see if there's any differences between the control group and the experimental group. So these components, the way that we're doing the conditions, really highlights the importance of random assignment. Remember, you want to have your participants, and then you want to make sure that you are randomly just assigning them to be in the control group or the treatment group. The the random assignment accounts for any possible systematic variation among the participants. So for example, if you said all male identified, you go in the treatment condition, and all female identified, you go in the control condition. And then let's say that we do find that there's a difference in how they're responding to their cancer symptoms, for example. Well, because there's systematic variation based on, gender identity, we actually have weakened our study because there is now an alternative explanation. Maybe it's gender identification that causes a change in how they're reacting to treatment, not the treatment itself. So you want to make sure that you're using random assignment as much as possible in an experiment. In fact, if you're not using random assignment, then it's no longer going to be considered an experiment. At most, it might be a quasi-experiment, and we'll talk about that in another chapter. So here's an example here. In terms of, remember, the purpose to having an experimental design is we want to determine cause. Remember, determining cause includes these three components. Temporal precedence. So we want to say, if you look at the blue circles there, we're trying to establish that it's watching television that increases aggression, right? So in other words, you need to introduce or expose your participants to television viewing and then measure their aggression levels, right? Covariation of cause and effect. Those are the orange circles. So is it that when somebody watches television, they have experienced aggression? That would be covariation. Then we would expect that people who don't watch television don't experience aggression, right? That's the covariation that we're looking for. So the only way we can figure that out is by manipulating the amount or the type of television that they're viewing and then measuring their aggression levels. And then green is alternative explanation. So we want to establish temporal precedence. We want to establish that there is covariation between the variables. And finally, we want to rule out alternative explanations. And this is the green circles. So what we see here is that television viewing impacts aggression levels, but only when parental supervision is lacking. And so this parental supervision is actually the third variable that researchers need to consider when they are establishing this design, this research design. Okay, so experimental methods. Well, number one, you want to have manipulation of your independent variable. So if you're looking at a research design and you're trying to determine, is this really an experiment? The first thing you should look for is, are they manipulating anything? If they're manipulating something, there's a good chance that it's an experimental design you're looking at. Are they controlling other variables, either through randomization or direct experimental control? So as you're reading through this study, is there any kind of sense that it should explicitly say if people are randomly assigned to one group or another? That's another hint that it's an experiment. Or is there any kind of discussion about maintaining control, making sure that all participants, wake up at 8 o'clock the next day, that all participants are having, a drink, 8-ounce drink at exactly 9 a.m. in the morning. Those kind of details would give you an indication if there is experimental control being exerted. And finally, we want to have unambiguous results. We want to be sure, right, internal validity, that it is the manipulation of the independent variable that causes change in the values of the dependent variable. So here's just kind of a pictorial view of establishing covariation, temporal precedence, and ruling out alternative explanations. So in terms of interpreting results, remember that we're going to manipulate the independent variable and randomly assign people into different groups. What we're going to do next is we're going to compare the groups on the dependent variable. So regardless of whether they're in the control group or the experimental group, we're going to measure a certain characteristic in the participants, and we want to see a comparison. What we want to see is that the experimental group had a change in the dependent variable, right? And what we want to do to really establish strong internal validity is you want to keep all the other variables, all the other extraneous variables constant, as I mentioned, through either experimental control and or randomization. So remember, the confounding variable is one that varies along with the independent variable and the dependent variable. So it's changing with it. If you don't control it, you can't determine which one is causing change in the dependent variable. So you want to make sure you identify it and address it to establish your internal validity. Let's talk about different experimental designs now. So the simplest design is a basic experiment, right? We have two variables. You have your independent variable. Level 1 would be you don't have the caffeine, for example, and level 2 is you have caffeine, and then you have your dependent variable of cognitive performance. This is, and we'll talk about different ways that you can strengthen the internal validity. Okay, so one way you can do this is what we call a post-test only design. In a post-test only design, you only take the measurement once. So you have two equivalent groups. You randomly assign your participants to one of the groups. You introduce the independent variable, right under IV, and then you measure the dependent variable. With this kind of design, it's not that strong because you're only measuring it once. And it could be, an argument could be made in terms of internal validity is, well, what if there's something going on with the participants? What if, even though we did random assignment, maybe some of them are a little bit sharper than others or something like that, right? So when you only measure it once, it's not a very strong design. It still can establish causation because you have temporal precedence and manipulation, but you're not ruling out all alternative explanations. So here's an example of a post-test only design, right? So does watching violent TV lead to more aggressive attitudes? In the experimental group, you have them watch violent TV. In the control group, they have them watch non-violent TV. So they're both watching television, and then you measure their aggressive attitudes. A stronger design than this would be what we call a pre-test, post-test design. So you have your participants, you randomly assign them, right, to control group and experimental group. Before you introduce the independent variable, you measure their aggression levels. In this way, you establish a baseline. You know already before anything else happens, what are their levels of aggression? Then you introduce the independent variable. Either they're in the experimental group and they watch violent TV, or they're in the control group and they watch non-violent TV, and then you measure their variables, the aggression levels again. So with the pre-test, post-test design, what you're looking for is not only change, you want to see a difference between the experimental group and the control group, but you're also looking, are there any changes between the pre-test dependent variable value and the post-test dependent variable value? So this is a much stronger design than the post-test only design, excuse me. Okay, so sample size. We talk about having participants. It's also important to consider your sample size. And so when we want to make sure that there is, minimizes a systematic variation, we want the sample size to be as large as possible. So the larger your sample size, the lower your chances of having systematic variation between people who are in the control group and people who are in the experimental group. When we talk about trying to break it down by demographics, for instance, you want to actually have about 30 or more per group that you want to break it down in. So let's say you're interested also in gender identity, right? So instead of just 30, you might have 30 male identified and 30 female identified. Now, let's say you're also interested in knowing, are there any racial and ethnic differences? So now then maybe you'll have a group, African-American male identified, African-American female identified, Asian male identified, Asian female identified, Caucasian male identified, Caucasian female identified. So now you start seeing how, those are 6 groups now. 6 times 30, it's 180. So the more groups that you're interested in kind of investigating, if those characteristics play a role as well, the larger your sample size is going to have to be. Now, it could be that you just, you don't want to break it down that way. We just want to have some people in experimental group, some people in the control group. Make sure you have a very diverse sample then, so that you can, the random assignment will actually be enough in terms of reducing systematic variation. So again, the larger the sample size, the lower your chance of systematic variation, and the higher your chance that you're actually going to find a difference between the groups that are in experimental group and control group on the dependent variable. So as I mentioned, the rule is about 20 to 30 participants per condition that you're interested in. All right, some pros and cons about post-test only or pre-test post-test. So if you do post-test only, you only have really high internal validity if your groups are equivalent. So that would mean, for instance, like the Stanford prison experiment, they went out of their way to make sure that all the participants were as homogeneous as possible. So they chose all white, upper middle class Stanford students. They even did a battery of psychological tests to make sure that they were, no one had any unusual aggression levels, that they were fairly even tempered. So they did all of that, same neighborhood, same school. So what they were doing there is that they were minimizing any possible extraneous variables. They were exerting experimental control because it wasn't going to be a pre-test, post-test, right? It was it's going to be post-test only. And so only by taking care to address all of these potential variables or changes, that's how you establish high internal validity in a post-test only experiment. What's great about post-test only is it takes less time than with the pre-test, post-test, because you're only measuring them once. Problem is that, there could be selection differences. In other words, is there a systematic difference between those who are in the experimental group and the control group? If you're not sure, that weakens your internal validity. So it is not also ideal for experiments that are conducted over long time periods. Now, let's think about pre-test, post-test. The pre-test is really strong because it enables a researcher to determine how equivalent these groups are, right? So generally you want to see in the pre-test that everyone has roughly the same scores. The focus in a pre-test, post-test is change from the pre-test to post-test. You want to see that those in the experimental group, there was a change in their value of, for instance, levels of aggression after the introduction of the violent TV was brought into the participants. What's nice with pre-test, post-test also is you get to see, if is attrition happening. So pre-test, post-test is going to take more time because you're measuring them 2 times, right? So it's more time consuming. It may also sensitize the participants to your hypothesis. If they're being tested on aggression twice, then they're going to know, oh, this study is about aggression. And so anytime participants are aware of that and it changes their behavior in any way, then that will weaken the strength of your study. All right. So when we do pre-test, post-test, oftentimes we'll talk about that as a repeated measures design. If it's post-test only, we're looking at that as what we call between subjects or independent groups. So in a post-test only design, participants are randomly assigned to conditions. They're only in one group. They're only in that experimental group. In repeated measures, the participants are in all conditions, right? So because they have their measurement before any kind of violent TV is introduced, and they have a measurement after as well. Matched pair design is a very strong way of having a repeated, sort of like repeated measures, but it's with different groups. So matched pairs, you first match your participants on a certain variable that's important to you. So it could be age, or it could be age, gender, education level. What you're trying to do in the ideal matched pairs are going to be twins, right? Because they're genetically the same. You're going to take one into purposely put one in the control group and the other one in the experimental group. So you're not randomly assigning in matched pairs. You're actually deliberately placing two individuals who are matched on some important variable, and you're making sure one is in the control group and the other one is in the experimental group. It's not used that often. Oftentimes we'll do that if it's impossible to have them in a repeated measures design. So oftentimes this is for a medical intervention or anything where the treatment will permanently change the participant. You would either have to do it as matched pairs or between subjects design. Okay, so independent groups or between subjects design. Each participant is randomly assigned to one group. The dependent variable is measured. What you're comparing is to see that the experimental group is not equal to the control group. Repeated measures or within subjects design, participants are assigned to all groups, right? The dependent variable is measured, and what you want to see, is there a difference, right, in the same people once the independent variable has been manipulated. So in terms of repeated measures, what are the pros? Well, you don't need as many participants because they're in all conditions. It's very sensitive to finding statistically significant differences, because now you're ruling out the extraneous variables of individual differences because they're the same individuals, right? So now you don't have to worry about that component. So as I mentioned, individual differences can be identified and explained. What's the con? Well, it limits its external validity if you don't have a varied group of participants. The treatments that create permanent change cannot use this design, as I mentioned before. And you could possibly have some issues from the sequence of the treatments that you're introducing to the participants. So some issues. When you're doing repeated measures, remember, they're going to be exposed to these measures more than once. So one problem that could happen is what we call an order effect. So the sequence of treatment presentation affects the dependent variable. There are different types. So if somebody does drinks coffee, for example, and then they drink coffee half an hour later, well, that effect of drinking coffee the first time is actually still going to affect when they drink coffee the second time, right? So that's what we call a carryover effect. The effect of the first treatment actually influences what happens on the second treatment. So you want to make sure, if you're doing repeated measures, you're leaving enough time in between the treatments so that that doesn't become an issue. Practice effect is what we call it when a participants' performance improves the second time. So improves because of learning. So this is even for cognitive performance, for example. What if it's not because they drank coffee that they are doing so well, but it's because they saw the test questions previously, right? So that becomes a problem. If participant scores improve the second time around, we call that a practice effect. There's also something called a fatigue effect. So that's when participant performance actually decreases. So it deteriorates, maybe because they're tired or because they're bored or they're distracted. Any way it goes, the second time around, instead of being consistent, maybe their scores go down. And we call that the fatigue effect. And then we have something called the context or contrast effect, where just being in the experimental condition causes the change, that it's not about the independent variable, it's just going through it that causes the change, maybe in the perception or something like that. So how do we kind of address these order effects? Well, it's something called counterbalancing. There are three types of counterbalancing. There's complete, Latin square, and randomized. So with complete counterbalancing, all orders of presentation are included. Right. So what we're doing here is maybe we'll have half of the participants in one certain order and the other half in another order. Right. So what we're doing is we're making sure that all participants experience the dependent variable, the manipulation of the independent variable in all combinations possible. So here in our example, we have the participants. We randomly assign them to order 1 or order 2. In this study, we're looking at the effects of feedback on somebody's self-esteem. So order 1, the people receive positive feedback, and then they measure self-esteem. Then they receive negative feedback, and then self-esteem is measured again. In order 2, they get negative feedback first, then the self-esteem measure, then they get positive feedback and the self-esteem measure again. So by counterbalancing this order, we actually get a sense of, is there an effect of having the positive feedback first or the negative feedback first on somebody's self-esteem? So when we're doing this, right, when we start introducing counterbalancing, then we need more participants in order to have all the different combinations addressed in terms of the different levels of your independent variable. So in a Latin square design, what we have now is each treatment is actually assigned to a different time period in the same number into each subject. So here, for example, we have different treatment orders. We have 4 different participants, and each participant is going to be randomly assigned to get one of these orders. So in order 1, they get A, B, D, C. And then second participant gets B, C, A, D. The third participant gets C, D, B, A, and the fourth participant gets D, A, C, B. So in a Latin square design, you're not doing complete counterbalancing, right? What you're doing is you're using random assignment to help you determine, are there different effects of the order? Because each participant is getting a different order, but they're randomly assigned to it. So you're still addressing the possibilities that the order does have an effect on the dependent variable, but you're not having each participant experience 16 different ways of having the order of the independent variable. So it's a systematic way of ensuring that the different orders are accounted for, but because you're using random assignment, you don't have to expose all participants to all combinations. And then we have randomized counterbalancing, where you're just randomly assigning participants to the different conditions. So those are the different types of counterbalancing. Matched pairs design. So as I mentioned, matched pairs design is a special type of condition where you cannot use repeated measures, right? Because for some reason, the independent variable that you want to look at may cause permanent change. So as I mentioned before, you match participants on a specific important characteristic. And what you're trying to do is get as equal groups as possible. So you're going to measure the matching variable in each individual. You rank their score, and then you're going to make sure that the participants rank approximately equal on the scoring, right? So you have the participants, you match them, right? Second stage, you match pairs of participants, you randomly assign them, but you make sure they're separated into the experimental group and control group. So you have the matched pairs, you make sure that that matched pair aren't randomly assigned into the same group. So you have to make sure that one goes into experimental group, one goes into control group, and then you measure the dependent variable. So this takes a lot more effort, right? So pros, it's useful for small sample sizes, right? Because you're matching, you have greater ability to detect statistically significant effects of the independent variable because you're already kind of matching on an important variable. What are the cons? Well, it's costly because it's time consuming. So that means you're going to have to pay people for more hours, the research assistants in terms of conducting the different matching and the testing that you have to do to make sure they're matched properly. Also, you have to make sure that your matching variable is strongly related to the dependent variable in order for it to be effective. So if your matching variable, maybe if you're testing on cognitive ability, you want to make sure that people who are matched on their IQ level, for example, something like that. So maybe you would look at both maybe gender, racial identity, and IQ level, something like that. You just want to make sure that the most important variables In other words, the variables that are related to your dependent variable are the ones that you're measuring these participants on. So here's kind of a visual. You have the matched pair, you have your participants, you screen them, and you have participants matched, and then you make sure you're randomly assigning one to the treatment group and one to the control group. And what you want to know is, are those in condition A? Were they not watching violent television? Are they equal to those in condition B, those who watch violent television? A key here is, remember, you want to make sure you're doing random assignments. You match them, and then you randomly assign them to the different groups. Okay, so it's important to know that there is a difference between random sampling and random assignment. Random sampling is when you have every person in the population has an equal chance of being selected for the sample. On the other hand, random assignment is when you, even if you didn't randomly sample, so many psychological experiments are based on general psychology students. So they're not really randomly sampled from the general population. What is even more important than random sampling is random assignment, because even if you didn't get a random sample, as long as you're randomly assigning, you are minimizing the chance that there's systematic differences between the people who are in the experimental group and people who are in the control group. So random sampling is when you're collecting from the population, everybody in the population has an equal chance of being selected. That's not always possible. So no matter how you do your sample, what is really important for internal validity is that you are engaged in random assignment, where you're not selecting which people go into control group and which people go into experimental group. You're making that completely random so that you don't have systematic differences. Okay, so determining types of experimental design. If the dependent variable is measured only one time, then you have a between subjects design. You could use block randomization or match group design to help increase your internal validity. If the dependent variable is measured after each level of the DV, then we're talking about a within subjects design. So remember, within subjects design, it's repeated measures. So those are the main kind of basic types of research design. We have the between subjects, and then we have the within subjects, right? And we have the post-test only, and we have pre-test, post-test. I'm going to stop sharing for a second. Any questions about the types of design that we looked at? So those are kind of really the basics of experimental design. Already kind of went through quite a lot. And I'm going to stop the recording right now, and I can start another recording if necessary.